These are the notes for section 8.2, the on-level version of properties of parallelograms. First, let's define the word parallelogram. A parallelogram is a quadrilateral that has two pairs of parallel sides. Okay? A clarifying example is right here. We can see that we can make two sets of parallel lines that are opposite. And likewise, here and here. You should be drawing these with me. All right, now let's check out the properties of parallelograms. We've got 4 theorems that we're going to talk about. Let's take a look. Our first one says if a quadrilateral is a parallelogram, then its opposite sides are congruent. Okay, that means we are looking at the horizontal sides and the vertical sides. In this picture, here we have BC, and it will be congruent to AD. And we have BA, and it will be congruent to CD. That's our first property. Our second theorem states our second property. If a quadrilateral is a parallelogram, then its opposite angles are also congruent. Now, let's look and see what opposite angles are. Opposite angles are on a diagonal. They are across the parallelogram from each other. In fact, as we draw in the diagonals, if you can imagine them, they start and finish the diagonal. So in this picture, angle B is congruent to angle D, and angle A is opposite and congruent to angle C. Okay, our third definition is if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Remember, supplementary means they add up to be 180. There we go. Now, consecutive angles, you'll see here are on the horizontal or on the vertical. I think I just did that backwards. Let's try it again. They're on the horizontal or on the vertical. What do I mean by that? Angle B plus angle A, my two vertical angles here, are side by side or consecutive, and they are supplementary. My other set of vertical angles would be angle C and angle D. They are side by side, they are consecutive, and they are supplementary. Now I've got them running on the horizontal lines as well. Here, angle A and angle D are side by side. They are consecutive angles, and they are supplementary. And my final set is angle B plus angle C. They are side by side. They are consecutive angles, and they are supplementary. That's a hard one to remember, so keep it in mind as we go along. Our final theorem is if a quadrilateral is a parallelogram, then its diagonals are bisected. That means cut in half. Okay, here we see diagonal BD. Let me put that in pink for you. And we have diagonal CA. In diagonal BD, we'll call this point M. BM is equal to DM. I should say congruent. And AM is congruent to CM. All right, let's see if we can work a few examples here. Our first one says, given JKLM is a parallelogram, list all congruent and supplementary angles as well as congruent segments. Okay, this is a tall order. Let's look at segments first. It's a much shorter list. Here we go. Segments. We're looking for congruent segments. I'm going to come back up here, and it says that opposite sides are congruent. So that means that KJ would be congruent to LM. And KL would be congruent to JM. All right, let's look at angles, and we'll look at congruent angles. We've said here that opposite angles are congruent. We said that opposite angles are on the diagonal. So my first set of opposite angles, angle K, is congruent to angle M. And now for my other side, I have to take the sum of those angles to be congruent. So we're going to say angle 1 plus angle 3 is congruent to angle 4 plus angle 2. Those are my sets of opposite angles. But we also have a transversal. So that means that angle 4 is congruent to angle 3, and angle 1 is congruent to angle 2 by alternate interior angles. Didn't think we'd see those again for a while, did you? All right, so let's go to supplementary angles. And see what we have. Well, we're going to go back up to this theorem right here, and it tells us that consecutive angles, or side by side, I'm even going to put side by side in this box, and I'm going to put a cross in this box so we can remember it better. We said that we normally, in this picture, we'll see them on the horizontals and on the verticals. Well, let's go along the verticals first. We have angle 5 is plus angle 1 plus angle 3. Those combined will be, add up to, the three of these angles will be 180 degrees because angle 1 plus angle 3 makes the entire angle of my parallelogram. We're going to do the same thing on the other side. We've got to combine angle 4 plus angle 2 and add it to angle 6 to also equal 180 degrees. And going on my horizontals, I have two of them. I've got angle 1 plus 3 plus angle 6, and that equals 180 degrees. And finally, angle 5 plus angle 4 plus angle 2 also equals 180 degrees.